Have you ever collected something you like? Maybe it's a collection of rocks you found in your backyard, stamps from different countries, or even a variety of video games. Collections can be fascinating because they bring together items that share a common theme or characteristic. When you think about it, these collections are more than just random assortments of items. They are organized in a way that makes sense to you. In mathematics, we have a special term for any collection of objects, and we call it a set. A set is a well-defined collection of objects. This means that the objects in a set are clearly defined and distinct. For example, a set of fruits might include apples, bananas, and oranges, but it wouldn't include a car or a book. The concept of a set is fundamental in mathematics because it allows us to group objects together in a logical and organized manner. This helps us to better understand and analyze the relationships between different objects. One important aspect of a set is that we can always determine whether a particular object belongs to it or not. For instance, if we have a set of even numbers, we can easily check if a number like 8 or 10 is part of that set. A set of even numbers contains all the numbers that are divisible by 2. This means that numbers like 2, 4, 6, 8, and so on are all part of this set. Sets are not just limited to numbers. They can include any type of object, such as letters, shapes, or even people. For example, a set of vowels in the English alphabet includes the letters A, E, I, O, and U. Sets are important in mathematics because they help us organize and understand information. By grouping similar objects together, we can study the properties and relationships of these groups in a more systematic way. We use sets to group similar objects together and to study the relationships between different groups of objects. This makes it easier to analyze data, solve problems, and make sense of the world around us. So the next time you organize your collection, remember that you are creating a set, just like in mathematics. We can represent sets in different ways. One way is to simply list all the elements of the set within curly braces and separate them with commas. For example, the set of even numbers less than 10 can be written as 2, 4, 6, 8. Another way to represent sets is by using a Venn diagram. A Venn diagram is a visual representation of sets using circles or other shapes. There are many different types of sets. A finite set has a limited number of elements like the set of months in a year. An infinite set has an unlimited number of elements like the set of all natural numbers. An empty set, denoted by curly braces, has no elements at all. A singleton set has only one element, like the set containing only the number 0. A universal set includes all the elements under consideration in a particular context. Section 4. Working with sets, set operations. In this section we will explore the various operations that can be performed on sets, which are fundamental concepts in mathematics and essential for understanding more complex topics. We can perform operations on sets, just like we perform operations on numbers. These operations help us understand the relationships between different sets and how they interact with each other. The union of two sets, denoted by the symbol U, is the set containing all the elements from both sets. For example, if we have set A with elements 1, 2, 3 and set B with elements 3, 4, 5, the union of A and B, written as AUB, would be 1, 2, 3, 4, 5. The intersection of two sets, denoted by the symbol, is the set containing only the elements that are common to both sets. Using the previous example, the intersection of sets A and B, written as AB, would be 3, since 3 is the only element present in both sets. The difference of two sets, denoted by the symbol, is the set containing elements that are in the first set but not in the second set. For instance, the difference of set A and set B, written as AIB, would be 1, 2, since these elements are in A but not in B. The complement of a set, denoted by the symbol, is the set of all elements in the universal set that are not in the original set. If the universal set U is 1, 2, 3, 4, 5 and set A is 1, 2, 3, then the complement of A written as A would be 4, 5, as these are the elements not in set A. Section 5. Sets are everywhere. We encounter sets in our daily life all the time. Whether we realize it or not, sets are a part of our everyday experiences. Think about the set of all students in your class, each one unique yet part of a collective group. Or consider the set of all books in your library, each book contributing to the vast pool of knowledge available to you. Then there's the set of all websites on the internet, a seemingly infinite collection of information and resources. Understanding sets helps us organize our thoughts and make sense of the world around us. By grouping similar items together, we can better analyze and understand complex information. Sets are a fundamental concept in mathematics that has applications in many different fields. From science to technology, and even in our social interactions, sets play a crucial role. Learn more about sets, and discover how they can help you understand the world in new and exciting ways. Embrace the concept of sets and see how it can transform your perspective on everyday life.